Good day everyone, I'm Teacher TINZ and welcome to my YouTube channel. In this video, we will discuss about theorems on tangent and secant segments. The theorem on tangent and secant segments. If tangent and secant segments share an endpoint outside a circle, let us consider circle A and let us draw a tangent line. And line BC is the tangent line of circle A. And line DC is the secant line of circle A, wherein the point of intersection between the tangent and secant line is point C. And in the theorem on tangent and secant segments, if tangent and secant segments share an endpoint outside the circle, then the square of the length of tangent segment is equal to the product of the length of secant segment and its external segment. And if we will write the theorem in mathematical expression, so we have line BC is the tangent, line segment BC, times line segment BC. So that is the square of a tangent segment. And it is equal to the product of the length of secant segment. Our secant segment is line segment DC. And then multiply it by the external segment or the secant external segment, which is line segment EC. And line segment BC is the tangent, so T times T, that is equal to line segment DC is the secant, and line segment EC is the external segment. And then if we're going to simplify, so that is T squared is equal to S times E. So that is tangent square is equal to secant segment times external secant. Let's have example number 1. What is the length of line segment BC? In the illustration, we have circle A. Line segment BC is the tangent line of circle A, and line segment CE is the secant line of circle A. Let's have now the measurement of the line segment. So line segment DE is 7, line segment CD is 9, and we're going to solve for the length of line segment BC. Let us write first the mathematical expression applying the theorem on tangent and secant segments. So we have line segment BC, that is the tangent, line segment BC. So applying the theorem, we have line segment BC squared equals the secant segment is line segment EC. That is the secant segment. And the external segment is line segment DC. After writing the mathematical expression, so we're going to write now the measurement of the line segment. Line segment BC is unknown. We're going to find the value of line segment BC. And then line segment EC, this is line segment EC. The measurement of line segment EC is 7 plus 9 equals 16. And line segment DC is 9. Okay, again, line segment EC. This is line segment EC. So 7 plus 9 equals 16. And the external segment is line segment DC, which is equal to 9. Next, we will multiply 16 and 9. So 16 times 9 equals 144. After finding the product of 16 and 9, we're going to extract the square root. So the square root of line segment BC squared is equal to BC And the square root of 144 is equal to 12. So the answer in example number 1, the length of line segment BC is 12. Let's have example number 2. What is the length of line segment BC? So in the illustration, we have circle A, line segment BC is the tangent line, and line segment CE is the secant line. Line segment BC or CD is the external segment. And the measurement of the line segment, we have line segment DE is 22 and line segment CD is 3. So we're going to determine the measurement or the length of line segment BC. First is we're going to write the mathematical expression of the given problem applying the theorem on tangent and secant segments. The mathematical expression, we have line segment BC, that is the tangent. So we have line segment BC squared, and the secant segment is line segment EC, times the external segment is line segment DC. And then we're going to substitute the value of line segment EC and line segment DC in the mathematical expression or the equation. We're going to substitute. So the length of line segment EC is 22 plus 3 is equal to 25. And the length of line segment DC is 3. So we have now the equation. Line segment BC squared is equal to 25 times 3. So the product of 25 and 3 is 75. So we have line segment BC squared is equal to 75. And then next is we're going to extract the square root of both sides of the equation. So square root of BC squared is equal to line segment BC, and the square root of 75 is 5 square root of 3. So the square root of 25 is 5, and then we will just write square root of 3. So therefore, the length of line segment BC is 5 square root of 3. Let's have example number 3. What is the length of line segment DC? In circle A, line segment BE is the tangent line, and line segment CE is the secant line. And the length of line segment DE is 4, and the length of line segment BE is 8. So we're going to determine the length of this line segment. So for the solution, by applying the theorem on tangent and secant segments, so we have the square of line segment BE, this is the tangent, is equal to line segment EC, that is the secant line, times the line segment ED, that is the external segment. Next is we're going to substitute now. So we have line segment BE is 8. So we have 8 squared equals line segment EC, that is the secant line. So here we have 4 and the unknown, which is line segment DC. So we have 4 plus line segment DC, that is for the secant line. And the external segment is line segment ED, which is equal to 4. And then next is we're going to simplify. The square of 8 is 64, and then 4 times 4 is equal to 16, and then 4 times line segment DC is 4 line segment DC. Next is we're going to apply the addition property of equality. We will add negative 16 to both sides of the equation. So we have 64 minus 16 is equal to 4 line segment DC. And then we're going to simplify now. 64 minus 16 is equal to 48. So 4 line segment DC is equal to 48. And then we're going to divide the equation by 4. So 4 line segment DC divided by 4 is equal to line segment DC. And 48 divided by 4 is equal to 12. So line segment DC is equal to 12. The length of line segment DC is 12. For example number 4, what is the length of line segment ED? We have here circle A. Line segment BE is the tangent line, and line segment CE is the secant line. Line segment ED is the external segment. So let's have now the length of the segments. So we have line segment CD is, or DC is 12, and line segment BE is 8. We're going to determine the length of the external segment. For the solution, so here we're going to apply the theorem on tangent and secant segments. So we have line segment BE, that is the tangent line. So line segment BE squared is equal to line segment EC times line segment ED. Next is we're going to substitute now the length of the segments in the equation. So we have line segment BE is 8. So we have 8 squared equals line segment EC, that is the secant line. So that is 12 plus the unknown segment. So we have 12 plus x times line segment ED is x. Next is we're going to solve for x. So we're going to simplify the equation. The square of 8 is 64, and x times 12 is equal to 12x, and then x times x is equal to x squared. Next is we're going to add negative 64 to both sides of the equation. So we have x squared plus 12x minus 64 is equal to 0. And we're going to determine the factors of x squared plus 12x minus 64. And the factors are x plus 16 and x minus 4. So x squared plus 12x minus 64 equals 0 is the same as the quantity of x plus 16 times the quantity of x minus 4 is equal to 0. And then we're going to equate each factor into 0 in order to get the values of x. So if x plus 16 is equal to 0, the value of x is negative 16. And for x minus 4 equals 0, the value of x is 4. So here, we will consider the positive value of x, which is 4. So therefore, the length of line segment ED is 4. Theorem on segments of secants. If two secant segments share the same endpoint outside the circle, so let's have circle A, and we have line BC is a secant line, and line DC is also a secant line. So these are the two secant segments or secant lines share the same endpoint outside a circle, and the common endpoint is point C. So in the theorem, the product of the length of one secant segment and its external segment is equal to the product of the length of the other secant segment and its external segment. So if we're going to write in mathematical expression the given theorem, so we have line segment BC that is the secant line, times line segment FC, that is the external segment, is equal to line segment DC, that is the secant segment, times line segment EC, that is the external segment. So we have line BC, that is the secant, line FC is the external, equals line DC is the secant, and line segment EC is the external. Let's have now example number 1, applying the theorem on segments of secants. So what is the length of line segment BC? We have here circle A, and line segment DB. Line segment DB is a secant line, and line segment DF is also secant line. So first is, we have now the length of the segments. Line segment EF is 5, line segment DE is 9, line segment DC is 7, and line segment BC is X. So we're going to solve the length of this line segment. We're going to solve for the value of X. For the solution, first is we're going to write the equation applying the theorem on segments of secants. So we have S, that is for secant, times E, that is for external segment. S times E is equal to S times E. So here we have line segment BD. This is line segment BD, that is the secant, and the external is line segment CD. And then line segment FD is the secant, and the external is line segment ED. So we're going to substitute now the length of the segments in the equation. So we have line segment BD is X plus 7 times the external, which is 7. And that is equal to line segment FD is 5 plus 9, this is 9, is equal to 14. And line segment ED is 9. Next is we're going to simplify the equation. So we have 7 times X equals 7X. 7 times 7 equals 49. That is equal to 14 times 9 equals 126. Next step is we're going to apply, or we're going to use the addition property of equality. We're going to add negative 49 to both sides of the equation, and we have 7x is equal to 126 minus 49. The difference between 126 and 49 is 77. Next is we're going to divide the equation by 7. So 7x divided by 7 is equal to x, and 77 divided by 7 is equal to 11. So the value of x is 11. Therefore, the length of line segment BC is 11. Let's have example number 2. What is the length of line segment FE? So we have circle A, line segment BD, and line segment FD are the secant lines of circle A. And then line segment BC is 5, line segment CD is 3, line segment ED is 4, and line segment FE is X. So we're going to solve for the value of X. For the solution, first is we're going to apply, or we're going to write the mathematical expression that applying the theorem on segments of secants. So we have S times E equals S times E. So we have line segment BD. This is line segment BD. Line segment BD times line segment CD, that is the external, is equal to line segment FD times line segment ED. Next is we're going to substitute now the length of the segments in the equation. So we have line segment BD is 8. This is line segment BD. So how did we get 8? That is 5 plus 3. And then times the external segment. The length of the external segment is 3 equals the length of line segment FD is x plus 4. So we have here x plus 4 times the length of the external segment, which is 4. Simplify now the equation. So we have 8 times 3 equals 24. And then 4 times x equals 4x. 4 times 4 equals 16. Next step is we're going to add negative 16 to both sides of the equation. And we have 4x equals 24 minus 16. Next is we're going to get the difference between 24 and 16. So 24 minus 16 equals 8. And then after that, we're going to divide the equation by 4. So 4x divided by 4 is equal to x, and 8 divided by 4 is equal to 2. So the value of x is 2. And the final answer is the length of line segment FE is 2. Thank you for watching. Please don't forget to like, share, and subscribe.